Have you ever had things break in production and you're not quite sure what went wrong? I remember the good old days when you had to go use things like tail and grep and then randomly click around the app to try and figure out what broke. You don't have to do that anymore, thank heaven. All you have to do is go sign up for Airbrake and then install it in your app. Airbrake is really simple. You get a little code that you put into your config file, and then you just install the gem. That's it. Really simple to set up. Then what it does is it aggregates all of the exceptions and errors that are thrown by your application so that you don't have to keep track of that anymore. It collects other information from the system as the errors occur, so parameters and things like that, depending on where the error occurs. And one thing that drove me crazy when we first started getting apps like Airbrake doing this work is that you would get 10,000 of the same error, and that doesn't happen anymore. Now they just aggregate it all together. You can go look at the individual errors and see where and what actually happened, but when it comes right down to it, they just let you know, hey, this error occurred 10,000 times, and then you go look at the individual ones so you can get them fixed. It's really easy to install. I already said that, but I just can't stress that enough. You take 2 seconds, you get it installed, and then you're off to the races. When I'm running a business, that time that it saves me is huge. So go check them out at airbrake.io/rubyrogues, and that'll let them know that we sent you. But seriously, just make your life easier. If you go check it out at airbrake.io/rubyrogues, you'll get Airbrake free for 30 days, plus get 50% off the first 3 months on the startup plan. So go check them out. You can thank me later. Hey, everybody, and welcome to another episode of the Ruby Rogues podcast. This week on our panel, we have Eric Berry.
Hey there.
I'm Charles Max Wood from devchat.tv, and this week we have two special guests. We have Daniel Azuma.
Hello, everyone.
And is it Parham? Parham?
Parham.
I have to mess up somebody's names or it's not an episode. So do you gentlemen want to introduce yourselves real quick?
Sure. My name's Daniel Azuma. I'm a developer at Google. I've been doing Ruby for about 13, 14 years now. And glad to be here.
Hi, I'm T. Parham. I live in Boulder, Colorado. I'm a co-founder and CTO of Neighborland, which is a civic engagement platform for city agencies and local organizations. And it's also built on Ruby on Rails. Before that, I founded, managed, and led technical projects for a small software consulting company for about 8 years. And I've worked with a handful of startups and small companies on a variety of projects over the years. And I've been writing Ruby code for about 10 years. And I currently maintain the RGeo Gems. I'm a maintainer on the Hamel team, and I've authored maybe 10 other gems as well.
Awesome. Now, Daniel, we had you on a few weeks ago, and T, I'm pretty sure that we've met at some Ruby events. So
we did. We sat next to each other at the Boulder Ruby conference.
Oh, right. In forever ago, the only time I went.
Forever ago. 2010, maybe.
That sounds about right. Awesome. Well, we're on to talk about what is it? Geospatial. I always stumble over this term, but it's essentially like mapping and coordinates and all that good stuff that we have in Ruby. Do you both want to just kind of give us some idea of what the landscape is here, as far as what people are using and how people approach this particular problem?
Sure, I guess I can start. So geospatial, as I see it, is just the set of technologies that has to do with location on Earth. So there are a number of kind of different parts to that. There's location, so latitude and longitude, and different ways to express location. So different coordinate systems. Computations that you can do to calculate things like distance, whether things are close by or within polygons or things like that. There's kind of the front end. There's rendering mapping systems. So you might be familiar with Google Maps and different kinds of technologies around there to visualize these things. Overlaying data on maps. So you imagine like a weather map or a radar map where you can see what's going on at different locations. There's different kinds of data formats, so you can get access to a lot of different types of spatial data sets, whether those are things like government data sets, so you can see things like census tracts and ways to categorize locations that way, as well as things like what's the vegetation that's in different locations, or what's going on and things. And then there's kind of a wide ecosystem of data that's available, some from government sources, from private sources. Lots of different applications that then you can do with this.
Cool. And I have a little bit of experience with this. The other question that I'm wondering about here is, T, you mentioned you maintain the RGeo Gem. So I'm just kind of curious what the history of that is, and how widely it's used, and what people are doing with it that way as well.
Sure. So Daniel is the original author of the RGeo Gem. So I took over the maintenance of RGeo and the entire family of gems. There are about 10 or so gems that are in use. The most popular ones are RGeo itself, and then the active record PostGIS adapter, which makes it easy to work with the PostGIS extension on Postgres within Rails. And there are a couple other ones as well. There's the GeoJSON gem, which makes it easy to encode and decode to the GeoJSON standard. So maybe we should back up a little bit and talk sort of specifically about what does RGeo do?
Mm-hmm.
I can start. I didn't write it. So any problems you have are all Daniel's fault. I'm just
yeah, that's right.
I just take the blame for it these days. Essentially, there are classes to represent basic geometries, like the simplest one being a point. But from a point, you can build line strings, polygons, and other interesting things like multi-points, multi-line strings, multi-polygons, and geometry collections, which are probably lesser used than the basic point, line string, and polygon types. And then once you have those basic types, you can do operations on those things, like, do these two lines intersect? Does this polygon touch this polygon? Does this line cross this polygon? Is this point within this polygon? So there are those are the basic geospatial operations that RGeo makes it a little easier to do.
It should be clarified that these types, points, polygons, they're actually very standard within kind of geospatial technology. There's RGeo implements a specification called simple features, which is kind of an open specification defining types of shapes that are useful to work with, as well as operations. A set of operations that can be done on them. So there are implementations of the spec in other languages. There's a commonly used one in C called Geos, and then there's implementations in Java and Python and different languages. RGeo is an implementation of this in Ruby, and it actually wraps the C implementation, the Geos implementation, because a lot of the operations can get difficult. Like calculating the intersection of polygons is. I mean, you can do it if you have enough, knowledge of kind of the computational geometry, but it can get tedious, and so we actually wrap a lot of this. We wrap the C implementation of it.
Yeah, that makes a lot of sense. My experience with a lot of this stuff comes, of course. This was 7 years ago. I worked for a company called Public Engines, and we had a number of products. The one that most people in the public would be familiar with is crimereports.com. And so I was lucky, and I was the one that got saddled with all of the geospatial stuff for our back end. And a lot of people, I don't think, realize, just how much this stuff gets used. So, for example, we were figuring out is this point inside of a polygon? And when we're talking about a polygon, just to give people kind of a visual representation of what that is, and you draw a shape on a map, so you can like outline your neighborhood, or you can outline a county or a state or a city. And we also dealt with some multiple polygon things because some of the law enforcement agencies we dealt with had jurisdictions over islands and things like that. And so when we're talking about polygons, it sounds really abstract, but really it's just a shape on a map. And you see that anyway, if you look at Google Maps, it's the shape of the block or the neighborhood or the island or the street or the peninsula or whatever it is you're looking at. And when you really start to think about that, then it becomes real. It's like, oh, okay, so in what ways can I care about the geometry of this area? And it gets really interesting really quickly. So, is it within this group's jurisdiction? Or, like for me, it was, oh, well, this is kind of the outline of my neighborhood, where I interact with people. So, what crimes happen within my neighborhood? And those are the kinds of things that we were looking at. Another thing that I ran into when I was doing this was that a lot of the law enforcement agencies used coordinate systems that were based around their local area because they didn't care about worldwide. And so latitude, longitude were these really big numbers that were hard to reason about and weren't fine-grained enough to really tell them where things were occurring. And so I had to translate that from whatever their coordinate system was to latitude, longitude, and a lot of the work there centered around that. So there are a lot of different interesting aspects of this that I don't think people really understand. And at the same time, I kind of wanted to draw that connection between the polygons and the lines and everything else with these are real things on a real map, and they represent actual areas where people live, work, and live their lives. So anyway, I kind of rambled there for a minute, but yeah.
I have a question for you guys. So I look at the gem that you've created, and Daniel, I'm looking at some of the documents that you have in there. One of them is an introduction to spatial programming with RGeo, written back in 2011. Now, it is an insanely well-written document explaining all about the innards of geo and the different types of data, data that you mentioned earlier, the spatial data types. What leads somebody to delve so deeply into this very niche field and create a library in Ruby for it? What drove you to create this, and also why Ruby?
Well, I guess as with many of these kinds of things, it was out of necessity. At the time, I was working at a Ruby startup, which was at the time called GeoPage. We had done actually this team and I had done a kind of a series of startups, all since kind of gone by the wayside. But at this time, we were looking at location and different things that we can do with location. So some of our products were like hotel concierge, where you could find different things that are around you around the hotel, and so we were dealing with a lot of data, collecting a lot of data, location type of data. Analyzing a lot of location type of data, so not only where things are, but how to get to places, what different areas around a hotel are easier to get to versus harder to get to. So there's a lot of kind of analysis, and then when we had to render this data, so we had millions of points in a database, and now we want to render that on a map. Well, we have to be able to search for what's nearby, and do things like filtering of data by area or by location, which is not necessarily something that a lot of databases do very well on their own. That's why we have things like PostGIS, which T talked about. So there are a lot of this. There are a lot of this functionality that we were trying to build, and we had done. We were a Ruby shop. We had done earlier products in Ruby on Rails, and so we were trying to build this also in Ruby. And at the time, there were some gems that did some things related to this, but they weren't really maintained very well, and there was a lot of functionality that was missing. I believe that some of the maintainers had particular problems that they were trying to solve, but we had kind of a wide variety of things that we were trying to solve. So I was kind of stuck. I was trying to use some of these gems, and so we were missing a lot of functionality. And so I just did a bunch of research online, found things like the spec, the simple feature spec, and started to see what the rest of the industry is doing when they're implementing these types of applications. So that's kind of where RGeo came from. It's like, well, Java has a nice library that does all these things. Where's Ruby's library? And so that's where RGeo came from. So that document, I actually haven't looked at that for many years now. As you said, it was written back.
Yeah, that's a good one. That's a good one.
2011.
So I went back in your history and I see that you had something like 300 some odd commits over the past looks like 10 or 8 years. And honestly, your very first commit is it's always interesting to me because it looks like your first commit message is not like initial commit. It is initial migration to Git. So obviously you've been working on this probably in SVN or something prior to moving it into GitHub. At what point during the life cycle during the life of this project, did you see that it started to gain more traction outside? Because typically on an open source project, initially it's like very much scratching your own itch, and then eventually your usage becomes smaller in the global scale of everybody using it. At what point did you see that it started becoming a default or de facto the go-to for the Ruby developers in geospatial development?
Yeah, that's an interesting question because I don't think that really happened until after I had actually kind of left this space.
You were the problem, Dan. We just needed tea. That's all we needed.
Yep.
Yeah. So back then, we had decided, well, let's open source this. This might be useful to other people. So we did that, and I actually did a RailsConf talk on it. I did a bunch of blog posts on it to kind of introduce the libraries and say, hey, here's some things that you can use if you're doing this in Ruby. And there was some interest at the time, but it didn't seem like a lot. I think most people who went into doing these applications just kind of by default went to Python or went to some other language. And so later on, I actually moved off of that startup and I joined Google and went into other things. And so I wasn't really maintaining the libraries as much, and eventually I had T come and take over maintenance. But it was around that time that I guess it takes time to kind of get start getting critical mass of interest in something. So it seemed like it was around that time that there was a lot more users, and so I think T can probably talk a little bit more about what's who's using it now and what.
I just want to thank you for not making me feel dumb, because if you released it open source about when you gave that talk, that was 2 years after I had written about half the stuff that you said is in that gem myself. I was like, oh man, where was, did I just miss this when I was doing it? And yeah, not quite the case. So yeah.
So T, when did you get involved?
Yeah, so I too got involved out of necessity. We were using the active record PostGIS adapter, and we upgraded to, I think it was Rails 4.2, I guess, and the innards of active model changed significantly, and the adapter didn't work. And so it was kind of the last thing that I needed, the last gem that I needed to work in order to do the Rails 4.2 upgrade. And I looked into the adapter and I said, hey, I can figure this out now. I'll start working on it. And
at this time, I had already kind of gotten off the gem. So I T had requested, hey, this is a problem. Can you help solve it? And I was kind of not as responsive as I probably should have been.
It's hard. It's hard to maintain, right? It's the developer dilemma. You got to go to the place that actually provides food for your family over everything else.
Right. It's free open source software. So I said, hey, I'll start work. I just started working on it, and probably naively thought, hey, this can't be that hard to fix. And then,
That's always the story, isn't it, with open source? Oh, that's not that hard.
Yeah, when you started, you had a full head of hair, right? I mean,
I'm very bald on the radio as well.
Yes, you are magnificently bald. I love it.
So anyway, what happened was I did the work, miraculously wrangled active record into behavior and got it to work on Rails 4.2. And then as I got into it, it was kind of a lot of work. And as I often do, just kind of went bonkers on fixing a bunch of other things or changing some style or making a lot of updates that were, as a pull request to a library might be ordinarily rejected or viewed as unnecessary overreach, or just this should be a different PR. This should be 8 PRs, and so the work had forked quite a bit. And for one thing, I didn't, Daniel wasn't really working on it a lot, and I wasn't sure if it would get pulled back into the main adapter, and I ended up just releasing it as a gem so that I could install it myself. And then I responded on the issue that, hey, I did all this work and it's in another fork, and I just renamed the gem since I have no idea if this will work on in general. And then Daniel said, hey, this looks pretty good. Like we should merge this back into the main project. And there's already a bunch of people using it. It's kind of confusing to have 2 different adapters. I agreed. And then he, mentioned that it wasn't really he didn't have a lot of time to focus on it anymore. And maybe I fooled him into thinking I had some clue what I was doing. And he asked me to take over the maintenance of all the RGeo gems.
How many are there?
Probably 10. I mean, I'd say there are 5 or 6 that are.
There were 8.
10
there were 8 that I originally wrote, and I think we split out a couple more.
Mm-hmm. Mm-hmm. I mean, the RGeo, the PostGIS adapter, and the RGeo GeoJSON are the most used. There's sort of an intermediate gem called RGeo Active Record that does some of the common active record stuff for not just PostGIS, but for there's a MySQL 2 spatial adapter and there's a spatial light adapter, but I have nothing to do with those anymore. And there is someone who maintains the MySQL 2 spatial adapter, but there's not a ton of work being done with that. And then I recently pulled out the Proj 4, which is a projection library. I extracted that functionality out of the RGeo gem so that you don't have to install it if you don't reproject coordinates, which most people probably don't. So it's one less thing to deal with when installing the gem.
So back to the Ruby question. I know that every language has its own pros and cons. We look at Python, and it seems like the Python's an excellent library for math. Where does Ruby shine when it comes to geospatial development? Where does it lack? Like, where does it sit on? Like, 'cause you compared it earlier to Java, Daniel, where you said that there was something for Java, but not for Ruby. Of all of the solutions that you're aware of out there, where does Ruby fit in as far as like, wow, it's super powerful and easy to use Ruby over other languages? Or is there any difference at all, would you say?
Yeah. So specifically for geospatial, Ruby is not necessarily the fastest language for a lot of mathematical computation. Although, to be honest, neither is Python really. But I think that definitely as a community or as a language ecosystem, Python and Java and some of the other languages have more embraced, say, mathematical or scientific computing to some extent. So that there's a lot more in that community where they wrap C functionality to do these sorts of things, and it's much more kind of embedded in that community. You think about, I want to do scientific computing, I'll just go to Python. It's associated with that, and not so much with Ruby. I think Ruby has tended to go a different direction. in general, our big thing was things like Rails, so ease of web development. Things like DevOps, I think, have kind of gravitated towards Ruby for whatever reason. So we have tools like Puppets and tools like Capistrano, and our community as Rubyists have kind of gravitated in those directions, and not so much in for geospatial. I don't know. I think at the time I was releasing RGeo, I kind of had it in my mind that maybe to try to work to change that, to see if we could expand the kinds of things that Ruby is traditionally known for, is traditionally good at, and maybe by producing some good libraries or we could help that happen. But I don't know. It seems like each language community has their own personality and things that we do in that community, and maybe that's kind of how it always is.
When you start a new project, typically you need things like a domain name, hosting, things like that. When I choose hosting, I pick mine for the options it gives. I like to know what I'm getting and set things up just how I like them. This is why, for your projects, you should check out Linode. Linode servers feature native SSD storage, a 40 gigabyte network, and Intel E5 processors. That's all the power you need to run VMs under full control, or Docker containers, who doesn't love that, encrypted disks, and VPNs. Plus, they have 10 data centers across the world and add-ons like backups, Node Balancer, and Longview to help you control your server costs. They also offer block storage for your static files, and you can get started with a $20 credit if you use the code RubyRogues2018. That credit is good for 4 months on their 1 gigabyte server. That's a lot of time to try them out and see if they're the right fit for you. That code again is RubyRogues2018. Also, if you're interested in working for Linode, they're hiring. Head to linode.com/careers to see their available positions.
I think a lot of it depends on the cases too. And just to speak specifically to the math question, yeah, Python outsources a lot of that to C libraries. There's a C library that sits underneath SciPy or whatever it's called that does all the heavy lifting for that library, and that's why it's as fast as it is or as efficient as it is because the Python VM isn't actually doing a lot of the lifting there. And I've seen other projects where people have actually written layers over the top of that with whatever core language they're using, and they're just hitting those same bindings that Python binds to. And, so there is the possibility of borrowing from that. I mean, that's why we're talking about RGeo wrapping over like Geos, is because then we can outsource to something that, is compiled and runs more quickly than Ruby. The other thing is that unless you need the edge cases that aren't implemented in something like RGeo, I think it matters less what language you're in. And so, when there's an implementation out there that is in C or C++ or Rust or something else that we can bind to from Ruby, it just opens up all the possibilities for any programming community to attach to it, either through FFI or some other system. So, it's definitely interesting to see what's been implemented, but I think a lot of times the possibilities there, even if we don't have it yet.
And I think that Daniel made an excellent decision in wrapping the GEOS, which it stands for Geometry Engine Open Source, which is kind of weird, but that is, I think interestingly, that's the C library that PostGIS actually uses under the hood.
Oh, really?
And PostGIS also uses the Proj4 library, which RGeo also wraps as well. So there are, I think leveraging those standards is an excellent decision, and it should be pretty darn fast. One of the you asked earlier, what are people using this for? And Daniel and I spoke a few weeks ago, and we asked each other that question, and the answer was, I don't know, besides our own personal uses. And so I actually opened an issue and asked people, hey, who's using this thing? I know that SeeClickFix was or is still using RGeo, since their technology director has contributed to the project. I think interestingly, I heard that Digital Globe, which is a satellite imagery company, is using RGeo. That was probably the most interesting response.
What do they do?
So they launch satellites and collect and sell satellite imagery and analysis software, I think. I'm not very familiar with them, but I did read a blog post that they recently, this is kind of interesting, they used a new Amazon service called AWS Snowball, which is Amazon drives a container to your building in a like 18-wheeler tractor trailer size enclosure, and you can load all your data onto AWS that way. When you have, I think they have on the order of hundreds of thousands of terabytes of satellite images, which was pretty mind-blowing to me that they're using. One of their developers said that they used RGeo to comb through their image database.
That's cool.
Wow.
Ruby in space.
Oh, that's awesome.
And there are a few, just to sort of finish that thought, there are a few like scientific apps that are using RGO as well. There's one called TaxonWorks, which is biodiversity informatics. It's a mouthful, but it sounds awesome. So yeah, I mean, I think in general, it's kind of, it's funny. Like we write this open source software, and then like who's actually using it? Like I don't know. We have like the download statistics from Ruby Gems, which are probably 95% CI servers, but it's hard to know. Someone start a company and figure that out.
Nice.
I remember back when I was first maintaining RGeo, one of the earliest, some of the earliest companies that actually contacted me and talked to me about features and things were actually some of the media companies, newspapers and things that were. So there were some media companies as well. I don't know if they're still using it. It's been a number of years since I've talked to these people. But
so where do you think it's going now that you have almost a decade of experience behind this? Where do you see the library going, and where do you see applications going when it comes to location tracking and location parsing and all that?
Crickets.
I see nothing. It's just black.
Well, it is a field that is, I don't know if it's like all the problems are solved, but I mean, mapping is pretty well understood. So I don't know. I'm curious to see where we do wind up, though.
Yeah. There's plenty of unsolved and hard problems out there for sure. I mean, I almost, anything in the real world has a spatial component, you're going to have to take that into consideration. So, I mean, in terms of the future of the project, I'd like to welcome anyone who has any knowledge or interest in this topic to contribute and become part of the organization, or whatever, do your own thing and do something else. This could be a tangent into broader topics on open source software in general, but I mean, I think it's interesting that Daniel did this incredible work to create this project and made a lot of great decisions, or these projects really. And I mean, for me, it's a volunteer project. I sort of work on it when I have time. And
what motivates you to do that?
T's just cool.
Maintaining a large project is not easy. So what makes you get in and keep doing that instead of saying, you know what, let's look for another maintainer, or hopefully somebody else will take it over and just let it ride?
That's a great question. I ask myself that question a lot. Mike Parham, no relation to me, was. I
would tell people there's definite relation, man. There's some street cred that comes with that name.
He recently spoke at the Boulder Ruby Night, and just this past week, and talked about how he turned Sidekick into a full-time job. He turned an open source project into a full-time job, and that was fascinating to me. And I mean, I think that those types of models, or more funding for open source projects and more financial support, those types of things are emerging, and they're often, things like Ruby Together, and they usually take the form of foundations, right? I mean, there's usually some sort of consortium of companies decide to fund things and make it possible for people to work on them and get paid for those projects. And I think there should be more of that. I don't really have an answer in terms of, how do you turn an open source project into something that financially makes sense for you? I think it's hard. I mean, I think for a lot of people, it just becomes crazy and they want to get out. So I've tried to think of it as a volunteering project and do what I can and work on things for fun. And ultimately, most people get into using and creating open source software to solve their own problems and to make their own software work. And that's kind of how I got into it.
Yeah, it makes sense. And it is. I mean, I've talked to a number of people across all kinds of different open source communities. And yeah, I've talked to a few people that work on some very large, very widely used projects that are like, I'm not getting paid on this. It's really hard to keep going on it. And so, yeah, just to see that, I started out working on my own, scratching my own itch. And, now I get to contribute in these ways that mean something to me. I think that's kind of the core and the essence of why a lot of people do open source.
It's a fascinating topic. I'm actually speaking on that very topic at the upcoming Ruby Hack Conference, which is different ways to approach funding for open source. So I'm very passionate about that topic myself. But yeah, I agree. There's got to be more motivation than just I need this working for me, because eventually you won't need it working for you because it'll be working, right? And then you got to have another motivation behind it, aside from just I want to do this because it's the right thing to do. Because honestly, the right thing to do is provide food for your family, and that's what it comes down to. But anyway, I don't want to get on a soapbox here because I could probably rant for 5 hours on the topic.
One thing that I want to jump in here with the mapping is one place that I see mapping and geospatial work in code going is that as far as like putting points on a map, drawing polygons, a lot of that other stuff. As I said before, a lot of those problems are solved, at least for the general cases that most people are going to run across. And what I think is really going to happen next is that people are going to want to correlate this data with other things that they have. Everything's becoming more connected. We're out there in the world where we have, our smartphone on us, which is collecting geospatial data. We have areas of concern, be it, maybe a warehouse or an office building or schools or whatever, where, we can track people through it. And, and then we have all of the other things that people post to social media or take pictures or things like that. And the place that I see things going mostly relies on people being able to correlate what they've done and what they're doing with geospatial data. And so I wonder a little bit, how do we make that kind of computing easier so that we can actually look at things and say, okay, these are the things that we know happened, and here are the locations that we know they happened in, and find meaning in that, if that makes any sense.
Wise words. Very, very wisdomous.
I just wonder how, is there an easy way to make those connections, or are the tools already there?
I think that there are certainly a whole lot of tools for answering simple problems. Mm-hmm. Quote simple. I mean, there are
right.
These things are, we can get into projections and what happens when you get close to the poles versus, what about altitude? What about three-dimensional things? I mean, these problems are not simple. They're complicated. And as you mentioned, there's just more and more and more data with spatial information tied to it. So, I've been fascinated by geospatial technology my whole life. It was sort of the first topic one of the first serious topics that really interested me in software development. So there's no limit. I mean, there's fascinating questions like, what about projections of coordinates on other planets? Other planets are shaped differently. Are we going to Mars? Like, what coordinate system should we use for mapping Mars? Right?
Oh yeah.
So there's no limit to the applications of geospatial technology. I guess if I had to put on my 50,000 foot hat for a moment.
Well, the other thing is that you mentioned that Mars is not like Earth, but how do we help people actually understand that at the same time? I mean, part part of it is we've got this data and how do we look at it, and the other part is how do we help people understand it. I don't know if I'm making myself clear. Well, what I see is I see that people are telling their story online, and the same thing. We go to Mars, we have the Mars rover, whatever else we happen to put on Mars, be it people or machines. So even under those circumstances, as it moves around, how do we convey that story so it's not just, oh, we found these kinds of rocks on Mars, but actual, this is what the Mars rover encountered. Here's the narrative that we can give to it. Here's, some of the historical narrative that we can give to a place. It seems like places don't mean anything without context. And so I like the idea of having these tools, but then making it easy to add the context.
Yeah, I don't think that's. The tools themselves are. They're just tools. They're one component of this wider narrative that you're talking about, and so for some applications, we need to deal with the fact that Mars is shaped different than Earth, and there's maybe some different mathematics that will have to go into it, and but then as we look at context, I think it's we deal more and more with the fact that narrative data it's messy. It's not just let's put a lat long coordinate on it and call it good. It's not quantitative. There's much more a connection to what people think or feel, or what's culturally relevant about what's going on, and so location can be a part of that. If you're in this city versus that city or this neighborhood versus that neighborhood, then something can mean something differently. That can enrich what's going on. But it's one voice in the entire story.
That makes sense. It's also interesting you mentioned that it's one voice in the entire story. And I mean, that's true. My experience is mostly with law enforcement data, and they look at that data completely different from me, who lives in the neighborhood that the data shows up in. And so, yeah, the context is different for different people. And that does make it hard to make it meaningful for everybody, depending on what the circumstances are and where we're actually looking at.
I think that's a good example of context, Chuck. I mean, you think about law enforcement data, you as a resident want to know, are you and your family safe? Are there trends that are happening in your neighborhood that you should be aware of for personal safety? It's pretty important. Whereas the police department, I mean, they certainly want to keep everyone safe as well, but they have a slightly different take on things in that they're looking at the community's response to their work. Really, this is the most important thing to them. I mean, they certainly want to. I mean, certainly their first priority is to keep everyone safe as well. But they're also concerned with sentiment as well. So, I mean, I think that's very important for everyone as software developers to keep, to have that context and have the perspective of, to be aware of what questions are we answering, what lens are we looking at things through.
Yep. Yeah, it's just an area that I've been thinking about a lot lately is, what's the larger story with our software? And so anyway, are there any topics that we should have jumped on that we didn't before we get to our picks? I'm going to take that brief silence as a no. All right, let's go ahead and do some picks. Eric, do you want to start us off with picks?
Hey, when it comes to health, you probably have some of the same disqualifications that I do. You sit all day, you run a busy life, and when you do make it to the gym, the only thing you're really qualified to do is turn the treadmill on. I was an athlete in high school, and so I could have thrown swimming in the mix, but that was about it. And I didn't really know what to do when I decided that I needed to get my health under control, especially since I have type 2 diabetes and I want to be around for my kids. So I contacted my friend JC over at DevLifts, and DevLifts, they did me a huge favor. Sure, it's a paid service, but what they did is they gave me a workout program. They also gave me some eating guidelines, and they have a Slack room where I can go and I can ask questions, and they give weekly challenges on things that I need to do differently. I really love it. So if you're looking for a way to get into shape, you're looking for a way to improve your health, then go check them out at devlifts.io. That's devlifts.io.
Yeah, I have a couple of picks. The first one is something that I've found Very, very cool. It's an email client that allows me to do many things. The email client is called Polymail, and it's a subscription-based service. But what makes it really cool is several things. One of them is it gives you insights into the people who are sending you emails, or you send them emails, and you can keep notes directly on that individual. So if you're having conversations on the phone or anything, you can actually log those conversations in the notes, and it'll stay with that individual. And you can also view all transactions with that person through just by clicking on their contact. It also has email open tracking, and it has the ability to create campaigns. So if I need to send out an email to 100 people where I can just swap out the variables, like here's your name, this and that, and then you can do that. It's very, very powerful if you're running a small business, mid-sized business. It also has the ability to share, so you can create teams in it. Anyway, I'm not getting paid to share this or anything like that, but I've been looking for something like this for a long time for CodeSponsor. And that leads me to my second pick now. By the time this airs, I believe CodeSponsor should be live. CodeSponsor is it's a platform that allows software developers who are working in open source to be able to make money on the side without having to change what they do. And that's kind of, we were talking about that a little bit earlier. But as a developer, if you want to make serious money, oftentimes what you have to do is change your role as a developer. Either you have to become a software maintainer, not a maintainer, but a support line, basically tech support for that project and sell tech support, or you have to turn it into a business such as Mike Parham did that we talked about. So what CodeSponsor allows for is to create an avenue of funding for that project or for the individual developer through ethical advertising. And we had a great 6-month run between July and December. We ran into some issues. We're relaunching in April, and I'm really excited for that. CodeSponsor.io.
Awesome. I'm just going to plus one CodeSponsor. I mean, any way that we can support the people who basically make our jobs easier without getting paid directly for it. I mean, folks, let's do it. Let's get the word out, and let's make sure that people know that they can get help to get this done. I mean, Eric's doing this, and it's a terrific effort. And, the more that we can do to support the people who are supporting us, under any circumstances, be it this or, any of the number of ways we have of contributing directly to a project. I mean, let's do it. I've talked to a number of people, and I'm just going to take my time for picks, and I'm just going to back Eric up here a little bit. I took a trip last November to New York City and wound up having dinner with a couple of people, Michael Jackson, who does React training, and a maintainer who asked me not to share his name, but he maintains a large project that's used across thousands and thousands and thousands and thousands of JavaScript projects. And, he works a full-time job, and then he works another full-time job to maintain this software that everybody uses. And he's saying, you know what, it'd be really nice if I could just go full-time on this project because it takes up so much of my time. And I know that there are other people out there that are working on projects that a lot of people use. And, they just don't have a great way to get supported. And, a lot of people don't see the need or have the means to donate. And so if we can find some of these other ways and help them out by, exposing them to ideas like CodeSponsor, and then, helping, if your company is interested in reaching developers, having them look at CodeSponsor as an avenue for advertising or anything like that. The bigger the pot is there, the more that we can help these folks out. And so, if you want to go to Open Collective and donate to it, great. If you want to, have your company approach CodeSponsor, great. If you want to find some other way to support them, either by helping do support or answer questions on their issues or anything like that, do it. I worry sometimes that some of these tools are just going to wind up, we go through 3 or 4 people that crash and burn on a project, and then somebody else goes and picks it up because nobody else is doing it, and then they crash and burn on it next. And you know what? For one, it just doesn't seem right. And for another, it's just kind of a reality that we deal with in open source that we really shouldn't have to. So anyway, those are kind of my thoughts, and I'm hoping that I can give you some ideas, even if you're not an open source person that wants to put CodeSponsor on their stuff, maybe you can help find an advertiser or, go donate on Open Collective or something, even if it's $5 one time, that'll add up. So anyway, +1 on Eric's pick, and I'm really excited to see where CodeSponsor goes from here. Daniel, what are your picks?
Yeah, I have a couple of picks, and I actually suspect that they may have been picked before because I actually may have heard about them myself first from from other people's picks, some years ago. But anyway, they both seem they're both things I've been thinking about recently. One is Project Euler, which is it's one of those kind of online problem solving sites where there are now over 600 problems that you can solve. Different most having to do with math, number theory problems, some geometry, some kind of different aspects of computer science. But you can use whatever programming language you want and solve them. And I think especially as I've been doing things like RGeo, which when I was working on it, they're exercising some computer science and some math and some algorithms that's I wouldn't normally have to deal with just doing I guess typical web development. And so just having the chance to flex those muscles, I think, and kind of exercise those muscles has been good for me as a developer, and it's been a lot of fun as well. Just every week or so, I'll just pick up a problem and start working on it. And I've been doing most of my problems in Elixir recently because that's a language that I've been trying to learn myself. So one's Project Euler. The other is not technical. I'm pretty sure I heard about this as a pick on one of your shows, Chuck. It's when I was growing up in the 80s, there was a comic strip called Bloom County that was really popular in the late 80s. It kind of ended sometime in the 90s, early 90s or something like that. But just I think about 2 years ago, it popped up again online. So there's a Facebook page, and the original comic strip author kind of revived it. And I heard about it pretty early on. I've been following it, and it is, if anything, even more funny than it was back in the 80s when it was incredibly popular back then. And I think especially nowadays, this has been kind of a difficult time for a lot of us in the country and in the U.S. with complicated things happening politically, complicated things happening socially, and kind of having an outlet to kind of laugh about things has been kind of it's been nice to have that kind of outlet or community. So Bloom County online, it's on Facebook. The comics author is Berkeley Breathed, so you can find that, and I'm sure there'll be links in the show notes.
Awesome. T, what are your picks?
Love it.
Okay, I've got several picks. I'll just throw them out there. The first few are geospatial related. There's the new company called Observable, which is founded by Mike Bostock, the creator of the D3 library and formerly of the New York Times, and also Tom McWright, who worked at Mapbox and on the OpenStreetMap editor and has also authored a bunch of interesting geospatial work online. So that's observablehq.com. They've got a maps collection, which is pretty cool there, where you can play around with spatial data and do your own data visualizations and data analysis immediately online. It's pretty cool. There's mapschool.io is a good resource for anyone who is just getting started with spatial technology. Geojason.io is a really simple mapping site that I use quite often to do things like sketch out a polygon and capture the coordinates of it. So for rough data sketching and just quickly visualizing and importing GeoJSON, it's a pretty cool site. I read a book recently called The Memory Illusion by Julia Shaw, which is a pretty fascinating take. It's by someone who studies memory, about essentially the mechanics of creating and restoring memories and how your memories are malleable. And an awesome quote from her is, all of your memories, even those that you most cherish, are prone to corruption and distortion. So that's a pretty fascinating book. My last one I'll take. Thomas Brinkman is he's a sound artist and minimal techno producer I've been a big fan of for a long time, and he just released like a multi CD or multi album retrospective called Retrospective. It's kind of like a 20-year greatest hits. So if you want to get in the zone with some techno and bang out some code, it's a pretty awesome music. I think it's on Spotify too, so recommended.
Awesome. Cool. All right. Well, one last question. If people want to find you online, where do they go? Do you have a blog or Twitter, or what are the best places there?
Sure. You can find me on Twitter and GitHub.
What's your handle?
Parham, TEEPARHAM.
Oh, that's easy. And Daniel, do you want to remind us where to find you?
Yeah, you can find me on my blog, daniel-azuma.com. And I'm also on GitHub as the DAZUMA.
Awesome. We'll go ahead and wrap this one up. Thank you both for coming and talking through this with us.
Yeah, thank you.
Thank you. It was a pleasure.
Yeah, thanks.
All right. Well, we will be back next week.
Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CACHEFLY.com to learn more.